Okay. Oh my god, Discord. Why do you do this? Am I frozen? I don't think I'm frozen. Oh my god. So I want to open Discord, but unfortunately Discord decided to upgrade and it doesn't let me run the old version. So let's see if Discord. So until Discord gets updated in the Arch Linux repositories, I have to run it from a tarball. Well, okay. I guess that's how it goes. Oh, man. We can ping everyone on Discord. Oh, crap. Really? That's not good. Everyone verify. Really? Oh, for Twitch? Oh, Twitch subs have the privilege. I don't know why they have that privilege, actually. Yeah, I specifically turned it off for like the usual roles, but I didn't realize that the Twitch sub came with it. The bots can ping people though, that's fine. Okay, alright. No, the bot ping didn't work because it wasn't enabled for the bot, but I will just ping now. Do you appreciate the massive problem requesting? Yeah, I appreciate the energy. Did it happen already? I wasn't paying attention. Oh lord. Yeah, okay. We have 8 problems already. Alright, well, let's play some FTW, huh? This button. The heck is this? Eagle. Okay, I don't. You know what? That's fine. I don't know what that means, but sure. Yeah, so for people that don't know, we have a Discord server now. I probably forgot to change the stream description, didn't I? This is stream number 42. That's gonna confuse me later. Okay, let's go. Troll. Wow, people are a lot faster than me today. Jeez, how do you do this? Dang it. I don't think I get this in time. Oh, people really... Either I'm a lot slower than normal, or people are really fast today. I'm not sure which. Yeah, I'm like off the chart. Oh wow. Ends up getting old. Pad 18. How do you type a square root? Thank you, Brian ZJK, for the 500-bit cheer. Alright, that makes sense. Fine. Oh, is it a 9th? I feel like I should know that. Okay, whatever. One, two, two, one, one, two, two. Very confused. What? How's that? Okay, so the big circle has radius smallest to largest. If the big circle is radius 6, then this is supposed to be radius 3. It's supposed to be 1, 1, 1, 3 halves. Oh, it does work. Okay, fine. Wow. Quite the party today. That was wrong, wasn't it? Okay, well I don't have to feel bad for taking a long time. It's one of those days. Thank you, Itsumi, for the follow. Thank you, Apps User 45 for the follow. Am I missing? I'm missing something. Oh no, that's it. Okay. Thank you, Fake Mom GT, for the follow. Thank you, Brian ZK, for the share. I hate this question. I've seen it before, I think. Really? Oh, it doesn't matter. Damn it. I see. Oh, yeah. That's wrong. 1634. It's 16, not 8. Okay. Thank you, Alps User 305, for the shout out to V Enhance. It's like if you press. What? Oh, it's how much to. Okay, well, today's gonna be one of those days. Oh my god. I'm not playing anymore after this. I don't think I got some time. When I requested that, I meant 2004 G7. I've probably done both of them anyways. Yeah, I've done both 2004 G6 and G7, so. What? Oh, yeah, that makes sense. I don't know what I'm doing today. Wow, I really don't know what I'm doing today. Can I get refunded then? Yeah. Oh, okay. What a day. What a day. Okay. Disaster. Okay, Pad. Do you still want to do the 1v1 request? Yeah, Pad? Is rejoining stream, okay. Yeah, we have one 1v1 request and then I'll go into math. I think I'm probably losing this request. Because today I'm not. Password is your username. I don't think we're gonna win after that. Password is always username. I don't mind spectators. Like, oh my god. Below L, waffle up, and then shove it. That's fine. Yeah. 1v1 is weird because when your opponent makes a mistake, you effectively get the point. That took a while to read. Jesus frick. What? I felt like I should have been able to figure that out. Alright! Didn't expect to win that. Okay, we have one more for NDX Pandy. Did I set the password wrong? Oh, okay. What? How do you even parse the question that quickly? Okay, well, this is not gonna end well. Oh, no, that's the other one. That was fast. F. Yeah, I mean, I feel like I'm like half as fast as I normally am or something today. Could I play you next? I see you're playing everyone. Does that cost money? Should I charge for FTWs? I don't think people want to pay to play FTW with me. Why are people redeeming Mute Me? I don't know. Did someone redeem Mute Me, Soul Winter, and... Are those serious requests? Okay, that looks like a serious... Let's take some effort. Yes, sir. Well, did I wait? Did you? Oh, people think it mutes me. Whatever. Okay. Ah, screw it. Okay, so will we start? Yeah, we'll do math now. For the Winter Edition is going to end pretty soon, which I'm not going to miss it too much, but I'm going to miss it a little bit. It was fun while it lasted. Okay. When Twitch stream will end, will there be breaks? Twitch stream ends whenever I feel like it. I don't typically schedule in breaks. Thank you 3DT for the chair. Alright, cool. So, what is on the menu today? When the stream ends, do you get t-shirts? No, sorry. Alright, so there are 10 requests outstanding. So this will take a while as usual. Okay, that's the first one. Mute someone else. So surprisingly, that was actually one of the suggested awards. Like, when you create the awards thing, that's one of the suggestions. I considered it and then decided against it. I admit it's pretty funny, but I decided against it. Okay, SL 2008 and 4. That's a Serbia problem, huh? Usmo 1988 6 98. Shit. Okay, Mexico down 23. I'm gonna have to shrink this. It's not gonna fit. Yeah, it used to be when the stream first started, I would get like 3 or 4 requests per stream and then we'd vote, and now it's more like 10. So it's a struggle to finish them all. Cono Sur 2020. Man. How do I find them? Why is this problem finite? Okay, polynomial. Okay. Tournament of Towns. The Tournament of Towns problem looks like another... I'm not optimistic about that one. Oh yeah, speaking of which, for people here, there is another USA TST next week on Thursday, so we're gonna have the usual bonus stream on Monday following. Yeah, TST hype. Officially TSTST, but TST. Wait, isn't this problem literally in my textbook? This Vietnam one? It's A0 to B0 IC0. Okay, okay. Well, that makes it easy. Refund points. Mark is complete. Alright. Oh, there's a 1v1 request that like a few minutes ago. Let's do it next time. I think I've kind of drawn out the FTW for too long. For data calc. Okay, so as usual, we're just going to vote it in 2 pages because it's too much to do all at once. Alright, submit your votes. Cool. Okay. I am not optimistic today. Today just seems like I'm not solving anything. Alright. Okay. And let's pull the right page. Alright. Have at it, we'll be right back. Alright, what happened while I was gone? Okay, thank you for another 1-bit share. What is this Google Drive thing? Is this okay? I don't know what the rules of it are, but that looks pretty funny. Okay. So it looks like the first two are going to be the N4 and the Cono Sur. So let's get started. Why no cool combo? I don't know. Ask the voters. For some reason I couldn't vote on my end. Don't you just like type a number? Does that work or something? Problem selection for harder 7 stream harder than problem selection. I don't know if that's true. Alright, so... Oh my god. I need to change the music back to chill. I'm gonna want my iPad for this one probably. This looks like a problem that has equations that are too long for me to LaTeX quickly. So, one moment, we'll be right back. Okay, so no one remember shout out to ZWJ? Oh, sorry, did I miss a shout out? Oh, I see, yes. Well, shout out to From Learner 102. Okay, so first of all, certainly all the numbers are odd, right? So all the binomial coefficients here are odd. You can either see this by computing the V2 directly, or you can... Okay, shout out to From Dotted Calculator. Or by Lucas theorems is the easier way to see it, I think. Like what happens is... Lucas theorem's not the easiest way to see it, actually. So by Lucas theorem you can get the... all binomial coefficients are odd. Now if I want them to all be different... Commerce theorem? I don't even... What is this commerce theorem? Does it kill the problem? Why would you... Okay, fine. Like, fine, okay. I feel like you should just lose Lucas for this case though. Like if you're only interested in whether it's even or odd. Yeah, sorry, I forgot the name. Yeah, that's fine. You're only interested in whether it's even or odd, you should just use Lucas. Or you just do it by hand. Now, the claim is that in all of them, they're also distinct modulo 2 to the n. So I feel like maybe what I want to do here is say like assume that 2 of them are congruent and then factor out a bunch of stuff and see what happens, because I know the binomial coefficients are odd. So what we're going to do is we're going to look at like just like 2 to the n minus a, choose 2 to the n minus 1, choose a, over 2 to the n minus 1, choose b. And let's say like a, b. Do I want the larger one on the bottom or on the top? Which one is better? The ability to get Evan's attention even in restricted chat. Yes. Yeah, I mean, if you want to get my attention and you're a sub, all you have to do is go into the Discord, go to Stream HQ, and speak directly. You'll be recorded by the stream, but I will also hear you. Sub perks. Hi, Dotted. Yeah. At some point, I should put the Discord overlay on here, where like you can see who is in the Stream HQ and so on. So do I want A on the top or A on the bottom? Oh my god, if someone recalls the stream, well, I'm pressing the deafen button. Do I want A on top or A on bottom? I can't decide. Whatever. So. Actually, you know, I feel like this is more natural if I use like A minus 1 and B minus 1. No, that's false. That's false. I retract that statement. This is... Okay, I definitely want A. I think I want A... No. Okay, and then the other part is just A factorial and B factorial. So we have this guy is congruent mod 2 to the n. Yeah. Yeah, so like stuff is gonna cancel, right? And what I'm worried about is that, well, do I know anything about the parities of what's happening here? So this is like 2 to the n minus 1, 2 to the n minus 2. Sorry, let's cancel out the common terms first. So are we A is less than B? So B times B minus 1 up to B minus A plus 1. I wonder if I should be using the fact that these numbers that I'm dividing out by are like both odd. Yeah, okay, so this original fraction is odd. Like the original fraction is odd, and then Well, we'll call this number x because why not? Let's call this x. It has both an odd numerator and an odd denominator. When it's rewritten by this, yeah, it should be less than equal to. Thank you, Blue Spider Monkey, for the follow. Yeah, okay, I don't think that really matters. But so this has some v2s in it. And so this is true if and only if. Because these are actually equal, the v2 of both of these quantities should match, which I find to be a bit of a surprising claim. That the v2 of the numerator of the new fraction and the v2 of the denominator of the fraction like are the same. Thank you, Yuhu, for the follow.
But it's not a thing about making it accurate. It's a thing about making it feel right.
Yeah, it was the, yeah, I got taken by surprise too. I thought it was Discord for a moment. I also feel like something is off here. There should be...
If it's an accident that's an error that feels good, then you leave it in.
I'm so confused. The heck?
You know, you want those.
Why does this song have lyrics? Let's... Escape song, all done. Okay, anyways. Man, why is this true? I'm like actually surprised the pump statement is true. I'm gonna pick some numbers. I feel like I can't see what's going on. So didn't you zero? It's just one. What does 15 choose 3? Jeez. Oh, today, I don't feel like I can compute that today. 455. Which is something mod. Yeah, so I'm trying to think, are these bits here like anything interesting? So you can see the consecutive terms are different. That's like that's a better base case, I think. Like, I feel like the better easy case is to say that consecutive binomial coefficients differ from 1 to the n because, well, they're kind of different. But I feel like I made a computation error already. Something about this expression doesn't feel right to me. It does, like, the number of terms doesn't look like it's matching. Right, because this should be a plus 1. Yeah, I was like, something doesn't look right there. Yeah, no, it's the blue stuff that's wrong. 0 to the n minus k minus 1 where k goes. What was the suggestion? 2 to the n minus 1, 2 to the n minus 1 minus 1. Look at the adjacent quotients. Oh, I'm sorry, Chenis. I hope you figure out what's wrong. Doesn't your idea just solve the problem? Maybe. Yeah, so the adjacent quotient is like, in general, if you have this is like k over 2 to the n minus k. And you want to show that some product of consecutive things is that. Share whiteboard? You should already have read access. So this is nominally negative. Thank you, Springbun, for the follow. This modulo 2 to the end, this is nominally negative 1. Oh, yeah, okay, okay, I see where this is going. So, like, this fraction is minus 1, like, this 9 is the negative of that. So, the thing that's happening is that it's being reduced. So, this is for k odd. And in general, the general form is that k over 2 to the n minus k is, like, congruent to... Okay, let's see. So if there's exactly a factor of 2, I cancel it. What does that do? Evan, do you think there exist problems which have absolutely no use in teaching? I feel like there are problems that have very little use in teaching. I think it's very hard to argue that something is like 0 use. Wait, okay, so if k is even, how do I compute this mod 2 to the n? Like I know that the v2, the fraction will always reduce such that the numerator and denominator are both odd, and it's like. If k, let's say like k is equal to 2 to the em, where m is odd and e is some non-negative integer, then this is equal exactly to m over 2 to the n minus e minus m. I don't know how to simplify that. I do think it's very important that, like, already the odd integers sort of pair off. Like, when I look at the, like, this 9 and 17 are form a pair, and this 9 and 7 form a pair. I would also indeed not be surprised if you did some sort of, yeah, reduced it to the previous case. I don't. Is there a relation between the... Yeah, okay. So, like, for example, modulo... Yeah, is there any relation between that and the previous case? So, like, mod 8, for example, you have a 1 to 7. You have a pair that goes 1, 7. And you have a pair that goes, what's 8 choose 2? 8 choose 2 is 28. No, sorry. 7 choose 2 is 21, which is 5. And then... Actually, I should just write out the entire number. I don't think I need to try to clean it. 8 choose 3 is 56. I keep doing 35. So these are negatives mod A, and then when you go to mod 16, it's 115. Fifteen choose 2 is 105. 15 choose 3 is... What's 15 choose 3? $18, 14. I competed earlier, got 455. I mean, that number doesn't matter. So, I wonder if something like... Thank you, Sepakoda, for the follow. I haven't read this, I hope it helps. I'm gonna, for instructional reasons, I'm gonna keep going. Cause I wanna push this line of thought. Like, I would really like if the 15 choose 4 is... So I wanna first know what these are mod 8. Like, does this match the previous sequence? And the answer is no. 1, 7, 1, 7. So what I want to claim is that, like, this whole bunch matches that. If so, that would just solve the problem. Let me see if that's true in general. Like, in general, 2 to the n minus 1 choose 2 is like... Yeah, this is always one mod. Yeah, so that's correct. It's like 1 plus 2 to the n minus 1. Okay, I think I know what I want to claim. This whole bunch lines up with that bunch. That's what I want to say. Yeah, so I think this is it. This feels like it's going to. This should do it. The claim. I need to write down the symbols and verify it does what I think it does. Claim. Let k be even. Then, like 2 to the n. Choose k. Is congruent to 2 to the n minus 1, choose k halves. Well, maybe I'll just make that. Okay, is that actually true? Maybe I should make sure it's true before I try to check it. If this is true, and additionally these are not congruent mod 2 to the n, which I assume shouldn't be too hard to verify, then that would solve the problem. I highly doubt that's true. Why won't you read my solution? Maybe I want to solve the problem. Okay, I'll read your solution. Jeez. What? No, I did. I tried to do something, and then 3VT loudly insists that he solved the problem and is making me read his typed up solution. So, like, okay. It's partial? I have no idea. Is this not true? This might be too good to be true. Yeah, I think the claim I have here is too strong. Let me check 16 choose 4. What is 16? What is 15 choose 4? Domain 65. Is it supposed to be -1 on the powers of 2 in the binomial? Oh shoot. Crap, did I mess up? Which binomials? I don't think so. Which ones are maybe? In the claim. I think the claim is also just probably wrong. Oh yeah, I see. You want the -1s here. Yeah. Yeah, I meant to put -1s here. But I don't. Yeah, so okay, this one is actually 5. So it pairs up with Yeah, sorry, so claim is definitely wrong. I thought for a moment it would actually just end up being like things pair up exactly, but I think that's just because the numbers I picked are small. Yeah, because 1365 is like 3 mod it. Or sorry, 5 mod it. Wait, what? No, this is fine. What? Hang on, maybe it's true. This is 5 mod. Okay, so it still pairs up. Let me write the k equals 2 case and see if anything happens. For k equals 2, what am I claiming? I'm inclined to claim that 2 to the n minus 1 or sorry, this is, I've written it this way, so it should just be any integer. And k equals 0 is true, so k equals 1 is trying to say 2 to the n minus 1, choose 4. This is gonna work. I feel like this is a little too clean if it's true, but we can give it a shot and see what happens. I don't think it's gonna work. Because there's a term that's like, this term isn't going to do anything good. It's gonna require me to modify my claim somehow. Yeah, that doesn't look like it's. Well, there's a chance. So let's cancel the factors, right? 2 to the n minus 2 minus 1. That's matched by this term here. Then 2 to the n, this term matches here. This might be true actually. Hang on, this might actually be true. I thought this was like nowhere, but Okay, okay, maybe we have something here. Oh, hold on, this might work. This. So first of all, I misspoke. This is k equals 1, but I think this has a chance. Alright, I have to be very careful because we're working modulo 2 to the n, and so some things won't really divide out. Although I know that this is an odd number. So, okay, let's do this in general. If this works, I'll be very surprised, but also it seems like it worked for the small case. For certain k, I think this should be k up to the point I need. We claim that... Okay, can you let me like finish my line of thought? If this doesn't work, I'll try your thing. Yeah, so I claim this. There's more parts where I want to also like. Yeah, we also have this part and this part. However, those parts look. Yeah, one of the equal signs is easy, and I think it should transfer over. So this main claim is the big thing I want to say. Yeah, I'm pretty sure that is actually going to collapse. I think it is actually going to collapse, in which case we are going to be very happy. So, let's look at the quotient. Again, because of Lucas, we know both of these are odd, so I can do the division. And the division gives me 2 to the n minus 1, choose 4k. Okay, so forget this thing about x. I'm not going to use this line anymore. Thank you, 3 dotted calculator for the chair. So the line we're going to instead consider is take the quotient of the binomial coefficients. Alright, sorry, this one's the top one. Okay, so on the top I have 2 to the n minus 1, 2 to the n minus 1 minus 4k plus 1 over 1 times 2 up to times 4k. And on the bottom I have 2 to the n minus 1. I keep messing this up. On the bottom I have 2 to the n minus 1, minus 1, all the way down to 2 to the n minus 1 minus 2k plus 1 against 1 times 2 times dot 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 times 2k. Okay, so first of all I'm going to deal with the factorial bits. So 2k factorial over 4k factorial, this is actually known to be equal to 1 times 3. So I'll take just the odd parts. 2k minus 1 times some suitable, hang on. Thank you, data calculator, for the chair. Yeah, this is going to work out, I think. Yeah, and then some power of 2. I believe that power of 2 is exactly 4k. So that's the product, and then here on the other side, when on the top I'll get 2 to the n minus 1 times 2 to the n minus 3 times times 2 to the n minus 4k minus 1. And then times the multiplier. Okay, so actually I should be a little more careful here. I think it's the same proof as before though, where for the odd parts. Alright. Well, what I believe is the exponents should match, and I think they do. But something is a little off because 1365 and 21 were congruent mod, like... Oh, are they actually congruent mod 2 to the n? Does this claim a true mod 2 to the n? Is it not 2k? Yeah, sorry, you're right, it should be 2k. I mean, the point is that we know the two addict parts will cancel out, right? Like it's like 2 to the something. I don't even really care what it is. Like it's 2 to the something, and then 2 to the something here. But because we took the quotient of 2 odd numbers, we know that that power of 2 will exactly cancel out. So really what happens is you can just ignore factors of 2, because when you do the write-up, you probably shouldn't ignore the factors of 2. But in principle, we know that the 2's are going to exactly cancel out. And so we only care about the odd parts, and I believe the odd parts look like this. Like here, each of these things would cancel into the thing above it to kill one term. Like each of these kills the double of it, and these are factor of 2, so those things go away completely. The same is true going the other way. Like the 3 here hits the 6 here and vice versa and leaves just 1, 3, and so on. And again, we're sort of just modding out by all the powers of 2. Denominator goes to 4k minus 1? Yes, guilty as charged. So I'm a little surprised that it's actually true mod 2 to the n, because it only is required to be true mod 2 to the n minus 1 to work. But now, once you kill off the powers of 2, then now I can just take mod 2 to the n. And, is there a sign? No, it isn't, right? Minus 1 to the 2k, so it's plus 1. So claim is true, and then... Yeah, claim is true, and that should do it. Yeah, so that should just work. I'm a little surprised that, yeah. So somehow looking at this thing, I was like, it would be so nice if this 1-7 was like this 1-7, and then it actually was. That's a minor miracle. I don't normally expect to get that lucky. Just read my overleaf. I feel like the overleaf is doing something different from what I did. Yeah. Like, I was just like, there's those two lucky. Like, is that gonna really work? And it really worked. Like, this 1365 and this 21. This 5 mod 8 is actually this 5 mod 8. They're the same one. They're actually congruent mod 16. Yeah, and then because the odd ones are negatives, and then the 2 mod 4 ones pair up with the 0 mod 4 by pairs like this, it seems like it actually just works. It's the same but in disguise. I don't know. This might sound weird, but can I have a clue on IMO 2020? I don't see what's weird about that. Like, if you want to ask for a hint on a problem, you just should. My hint for you is that you should think about why the number of items is a perfect square, like n squared, because nothing else in the problem seems to suggest that there are squares involved. That's how I managed to come up with the construction, and once you have the construction, it's much easier to prove the bound, I think. Okay, that's cute. I like this problem. What's next? The Mexico problem? Or no, Cono Sur is next. This problem looks so hard. Or not. I don't know. So I look at it and I'm not that happy or something. Okay, so I need to fill a 4x4. There's a typo in the statement that I got from AOPS. Some of them, in each of them, some of them, the 4 numbers is 5? Or something? Okay. So my first feeling when I see this is, oh god, here we go. Like, there's gotta be a lot of... No. Actually, how do you construct one? I feel like there's so many constraints. Summon numbers in each row or column. The diagonal is also summed to 5. And in 4x4. The heck is this? Does that work? And you put zeros everywhere else? Oh, they're up to rotation, like... This condition here, I think, is the most obviously useful one. I just want to find all the boards and then I'll deal with this log later. I think the condition is saying like this long diagonal and this long diagonal need to add to 5. Okay, well I found one. Can you just assume that the corner is 0? No. You can almost assume all the corners are 0. But I think there's one sporadic case of this shape. Yeah, the one case seems like it's an easy one to deal with. If all the numbers on the board are at least 1, then... Okay, so this condition is not completely useless. Okay, fine. I thought it was just to remove some symmetries. But actually it tells you that you can assume that one of the numbers is 0. Like there's a min, that min should be 0. If the min is 1, then I'm looking for the number of ways to place one token in each of the 4 squares, such that so and so. So this is like up to rotation, like the quote unquote left, also up to reflection as well. But if all the numbers are at least 1, then you subtract 1 from everything, and then it's a lot easier to think about. All you want to do is find ways to place the 4 2s. You know, there's 1 in each row, 1 in each column, and 1 in each 2x2 square. So you just kind of run it over. I'm waving my hands here. Yeah, I'm sorry. Let's pretend though it's like the lower right or something. Yeah, rotate. I don't. Yeah, so the case where the min is 1, I think, is easy. For this reason, you can by reflecting, if necessary, you can assume either the 2. Okay, you know what? Let me put the upper corner in the right place, just so I don't confuse people too much. Man, I'm so used to the other corner having the symmetry that this is actually hard for me. Okay, cool. Yeah, and then this case will look a lot like it. Yeah, so if there is a min, if the min is 1 and it's in the upper left, then by rotation or reflection, you can assume, well, by reflection, you can assume the 2 is either like in this cell. Yeah. It's like this cell. Is either where the 2 is or the something. Yeah. Can't this just be bashed? Well, that's probably what we're going to end up doing, because the problem is so finite. Yeah, so here there's on the order of like 8-ish cases. So the hard part is, well, I guess we just kind of assume that alright, let's assume that 0 is there. And now here we are. Oh, Jesus. What am I supposed to do? Like, Ah, this is so... Oh my... Fill in a random 2x2 and see if it determines everything. Yeah, honestly, most of that's it might determine a lot of things. To have. Like, suppose I call this number x, this number y, and this is like 5 minus x plus y. Okay, so then a lot of things add up to the other. So this thing should add up to... This thing adds up to 5 minus y. This thing adds up to 5 minus x. This thing adds up to x plus y. This blob adds up to y. This blob adds up to x. That's sort of redundant. So what conditions do I have left? I need like... Oh, Jesus. In each 2x2, you can shift values by adding all... Oh no, okay. So, the claim is that 1, 1, 1, 1, minus 1, minus 1, I know. The sum of everything involved here is 0, so I can add copies of this. Oh, jeez. I think you're right, and I'm very sad. No. I need to flip a thing. Like that. So that black thing has sum 0. Right? That's awful. Okay, so there's going to be a lot of solutions, is what I'm seeing. Even if I fix the left half of the board, I can make things happen on the right. So I definitely need more variables. Actually, in fact, like... in a given... No. Yeah, unfortunately the equations are kind of redundant. Yeah, oh jeez. Oh jeez. So people are telling me there's 5 dimensions. I have how many set right now? 1, 2, 3. You can choose 6 cells, not just 5. Oh my gosh. Oh, this is gonna be fun. Alright, so there's my is the 6 cells that track count is getting include the 0 here? Not including 0. Heck. Okay, well, let's do the following. We're gonna use the very advanced strategy called make a big table. And I'm just gonna write stuff out because I feel like at this point I'm just being too shy. Ha! So we picked 0, x, y. This is 5 minus x minus y. I'm gonna make one more choice here. Let's call it z. So this is x plus y minus z. I gotta pick 2 more things. So I'm going to pick like things on the diagonal, like this one and this one. Call this a, b. So this is 5 minus a minus b. Or no, that's not what I'm saying. Just 5 minus a plus x. This is 5 minus b plus x. No, 5 minus b plus y. And then what are my conditions? Like, I want to solve for this stuff, right? And I have, so there's 4 variables here and there are 3 equations. Or the equations are consistent with each other. And there's like, actually no. There's these, this dot determines this dot because through there. And okay, so this dot and this dot are the weakest ones, right? They're not involved in anything other than the row column and I'm losing track of which ones is redundant. Isn't it just x minus a? Isn't it just 5 minus a? Oh, did I get a sum wrong? Yeah. This is y minus b. Okay. No, I don't think it's promised that isn't it square. Yeah, okay, cool. So if I believe Twitch shot, I get 2 more variables. So I'm going to... I was hoping I wouldn't have to break symmetry. I might have to break symmetry. Okay, we're breaking symmetry. No, hey, I have a variable here. Maybe I just don't want that variable. You know what? I'm not gonna deal with that. I want things to stay symmetric for as long as I can keep it that way. I think I won't be able to keep it that way much longer. Yeah, okay, I have to break the symmetry eventually. Alright. P. This is a variable P. Five minus X minus P. A plus B. This is unfortunate. I don't know who suggested this problem, but no, never mind. I'm gonna try to make it so that none of the things have more than 5. Because otherwise the basis is gonna get really bad. I'm gonna pick A and B here and like I need this basis to actually extract an answer afterwards. So I don't want there to be like a 5 variable thing. Okay. Do middle 2 rules plus diagonals minus 2 side columns, and I think you get 0. Oh, there's an integer condition. Interesting. Okay. Thank you. That will save me a lot of work. So the condition is there's an integer condition that goes like if I add these guys and then I add the diagonals and then I subtract off this one and this one, I get 5, 5, 5, 5. Okay, so these guys add up to 10. Wait, why does that help? No, it just means the middle square is also 5. Okay. Yeah, so... yeah, center adds up exactly to 5. Okay, that's fine. Okay, and that if that's the case, then maybe I'll pick the variables here anyways. So it's like 4 numbers. Yeah, this condition's fine. It's like a plus b plus x plus y is at most 5. So that puts quite a bit of constraint on those 4. That will be useful. And this number is like x plus y minus a plus b. In addition, we now determined this number is b minus y. This number is x minus a, so I messed up. This is y minus b. Okay, so now I need like some more variables. Corners add up to 5. Yeah, that sounds right. No, actually the corners, because this center square adds up to 5 and like the diagonals adds up to 5, it means that oh, I finally figured out how to get more colors on this thing. Okay, so bottom right is equal to a plus b. This thing? Yeah, that's good. So yeah, good. Okay, so now can I start chucking in new variables? One more to check. I thought I had 2. I thought you guys one more variable. Okay, alright. Let's call it this is the one that breaks symmetry, so I want a letter that doesn't feel symmetric. K. Alright. 5 minus y plus k plus a. Y plus k minus b. Uh, 5 minus x plus y plus k. And that should check out. Yeah, okay. And this is 5 plus b minus x plus... Okay, so I managed to avoid getting 4. variables, I think. Wait, what? Is this like minus k plus? Oh, it's just k plus a. I have solved in terms. Oh, sorry, I didn't see the second overleaf. Well, we're here now. Sorry about that. I just didn't see it. It's the same overleaf? Well, it's not like I had it open after the other problem. Okay, so problem is, well, okay, now we have this. So we have variables. We want number of choices of a, b, x, y, k in the set 0, 1, 2, 3, 4, 5 such that 7 gazillion conditions are true. So let's try to be as intelligent as I can about writing these out. So a plus b, x plus y, up to 5. Yeah, I'm gonna check these off as I use them. This one's done. This one's done, this one's done. X plus y, x plus y plus k. This one's done. K is automatically non-negative. Yeah, they're always automatically non-negative. K plus a is less than or equal to 5. In fact, it should be less than or equal to 5 minus. Less than or equal to 5 minus y. Y is at least b. Alright, this y plus k is at most 5 minus a. And at most 5 minus b, so... now I'm just confused. Okay, undo. We're stepping back. Oh my. Can we characterize this number of k? Well, x. Okay, that's a fair point. So maybe I should think about k last, and so say first choose a, b, x, y, and then I look at the things that only involve a, b, x, y, and they're like these things. So I had the requirement there's a requirement that b is at most y. that should have a parallel requirement, right? By symmetry, it should imply A at most x. Okay, and then what are the constraints in K? Then, like, K. So K is not negative and it's not, okay. So K is less than like 5 minus 5 plus A. Alright. B is at most Y, because Y minus B is in the grid, so B is at most Y. K is at most 5 minus x plus y. So one of these is bigger than the other. Which one is more restrictive? It's the A one, right? Because A is at least... It's the X one, because X is at least A. So that one's done, that one's done. Y is at least B, so this is automatically non-negative. And then... So everything, so there's a other part, 5 minus y plus b. That's redundant because, okay, that's obviously redundant. So that one's fine. K plus a, so k should be at worst 5 minus a, but that's redundant because k is at most 5 minus x plus y, so that one's okay. And finally, k is at most 5 plus b minus x. Oh, so they're all, most of them are redundant. It's just this one. Yes. Wow. Wow. So these conditions are necessary and sufficient. A plus b at least 0. X plus y at most 5 not necessary. I guess, yeah, it's implicit from k out about us by y. Yeah, okay, so I'm not even sure that I... So A should be at most X. Maybe, so okay, maybe I don't have to treat K specially anymore then. I thought because there were so many conditions on K that I wanted to make K special, but it doesn't need to be. This is it. In fact, we should sum based on like X plus Y plus K. So, let's go back into math book. Then what I want is the sum of X plus Y plus K. Okay. I mean, I'm saying they're from 0 through 5, so I assume that, you know. I'm looking on the thread for the nice solution. Don't worry, the thread is empty right now. No. Okay, I'll write 0. Oh, fine. Well, so there's a thread if you search the keyword, and it doesn't have a reply now for... I mean, I can't blame them for not having a reply. So... Your formulation is even nicer. Are they non-negative from 0 through 5? Z equals x minus a, w equals y minus b. But then like a, you need a condition that like a plus z is at most 5, right? If I take z equals x minus, oh. Okay, I'll read for drama size. So we'll let, yeah, I was gonna just pick x, y, and then like, Oh, x at most 5 is automatic. Okay, fine. So we'll let x equals a plus u, y equals b plus v. Okay, so then we want u plus v plus x plus y plus k at most 5, where all the variables are non-negative. Is that it? That does appear to be the only constraint. Wow, okay, so by thank you Queppy for the follow. So by so I believe I am supposed to refer to the sticks and stones method as the name. Anyways. Yeah, it's the same thing. Yeah, but less than or equal to 1. Exactly, yeah. If the min is 1, then it should be ditto. So our sticks and stones method. Is it not the same? Wait, it's at least 0. Oh, sorry. I meant at least 0. Yeah. Of course. Okay, so let me get this right. I have 5 objects and I have 5 variables, but it's a less than or equal to, so it's really 6 variables, so I want to put 5 dividers. So 10 choose 5. Like I want 5 dividers and then I want 5 objects. So it's 10 choose 5, right? Is there 9 choose 4? It's 9 choose 4 if this is equals, but it's less than or equals to, I think. Am I a crazy person? Oh, jeez. We dodged all the casework and we ended up here. Four bars, 5 objects. No, but it's less than or equal to, right? So like it's really yeah, I'll write it out. There's a 6th, you can treat it as a 6th variable, and so 5 dividers. I don't believe this result still. How many are there with upper left equals 1? Yeah, it should be 6, I think. 6 sounds believable to me. I think 6 is right. Wait, why do you need u plus v plus x plus y plus k? I mean, that was the x plus y plus... Oh, sorry, I misnamed the variables. Oh, freaking... A, B, A, B. Yeah, it's A, B. Yeah, you are correct. I substituted the wrong variable in. The other case. we want them to have some one. Yeah, the other case is small enough we can do it by hand. So final answer 258. So people are saying that this is not the correct answer. Is it? I don't know. Should I run a program to check it or something? U, V, A, B, K. U and V aren't, I think. Like A plus U and B plus V are not. H is also not actually in the... A program might take forever. I mean, it depends on how much like if you do a brute force search for this, like with these variables, I think it's fine, right? Like we have this board, and I mean, you look at it, I think it's very unlikely we screwed up this board. Like, you know, you can check that all the conditions are true, and then what you do is you have to run through the variables and see which ones actually lead to valid boards. Oh, U is at 2, 4. Ah, U and V are there. And then H is... Where's H? So H is like 5 minus x plus y plus k. Ah. Oh, huh. Okay, so... So what this means is... I think you're right. I think we could have picked a better basis now that we know these variables. Oh, that's probably the one that 3VT sent me then. That's why I was so excited about it, huh? Like... Yeah, U is here, V is here, A, B, this one. Yeah, these 6 entries are the ones to pick, I guess. And I assume 3VT got that. Oh, you didn't get that. Okay. You're so excited about it. I assume that you had the one that was optimal. That's fine. Yeah, then it's these. Oh, wow. It's these 6. These 6 are the ones to pick. You don't get any negative coefficients. Or you don't get any subtraction things. Wow. Did not expect to see that one coming. Okay. Contestant solve took 11 pages. Yeah, that sounds about right. I feel like we missed a condition. I feel like you're not gonna get anything cleaner than this, right? Like, okay, let me write it out that as we claimed. So the claim is the following, that if I take those 6 entries, that determines the board. And so, right, I'm gonna put all right. Well, now that we know what's happening, I'm just gonna use different letters. A, B, C, D, X, Y. And my claim is that any choice here will work. because with the condition the sum's at most 5. Because first of all, this is 5 minus a plus b. Because of this thing equaling that thing. And then this is 5 minus c plus d. So this is like a plus b plus c plus d. And then because we know that this, the heck, that's not supposed to happen. Sorry, I'm being silly. C plus d, and this is 5 minus a plus b plus c plus d. And then you pivot and say, okay, well then this number, because this is 5, this is c plus d exactly. Or sorry, b plus d exactly. So this is 5 minus b plus d plus x plus y. And then that gives you everything else. So yeah. Yeah, so the point is we'll get exactly one condition, which is that on this major diagonal, a plus b plus c plus d plus x plus y is exactly equal to 5. And everything other than that is vacuously satisfied. And also, if the sum is actually 5 and they're indeed non-negative. Yeah, so it's more symmetric than we thought. We just didn't pick the right variables, but this is the best choice. Yeah, we get... Okay, wow. That is really surprising. I don't expect a basis like this to typically exist. Yeah, I'm so, like, what is this? Okay, we're done. Yeah, this is... So you can do this with 5 replaced by any number, if you assume the upper left is 0. So, this condition... I initially thought this condition... The first thing I said when I did this one was that this condition is useless, and it turned out to be the most important condition, because it's the only reason that this works with 5 replaced by something else. If you term upper left greater than 0, then subtract. Well, you need to assume the upper left is the min. That's the important bit. Like, if the upper left isn't the min, then this argument may not work so well anymore. Yeah, but then if you assume the upper left is min, then in general the answer is the sum of like we had here, it was 10 choose 5 plus 6 choose 5 plus so on down, and in general it would just go down by 4. So it's the final answer 258. I'm ready to declare 258 is the final answer, unless I have made some terrible mistake. But I mean, look at the board. Your inequalities are just different. So what? The condition is like the things need to be at least -1? I'm asking contestant, 1 minute. Oh, you verified it on Scratch. Okay. 3 minutes of coding? Well, I mean... No, I think the intuition for this problem is that, like, this is a, like, there are some linear conditions and you need to pick, if you pick so and so many numbers, it will determine the rest of them. And then you just need to pick which 6 numbers are your basis in such a way that there's too much casework. And somehow magically there is one basis where, yeah, somehow there's just one magic basis where everything just works out amazingly. But like, even if the conditions had been slightly worse, we would have still been able to solve the problem. Yeah, like... This is also forward written, is presume. Probably. Okay. I don't... So, how do you think of this backwards? Yeah, I guess you probably can. Okay. I have some... How do I want to do this? I don't have a scene that just shows mostly me. Maybe we should make one. That's good enough. I have some new plushes. We get the game for the first time? Oh, the camera got confused. Do we get the game? Yeah, maybe we should. We've done 2 problems, which is like okay. I'm trying to... What's the next one? That's the Mexico one. Oh jeez. I feel I should at least try the Mexico one, but I might not try it for very long. Can we do a TSTST one? One more is good enough. And then someone submits a different problem. Did you like the problem? I am much happier with the problem now that I've seen the solution than I was before. I thought at first that there was no way there would be anything that looked like this and you just had to like grind through a gazillion cases. But now that I know the solution exists, I'm a lot happier. I think I'm happy that I know that there's something like this out there because I didn't expect it to exist. Now if I was a contestant, I would probably be a little more sad because I do not think I would have found this on the contest. TSTST does not have ISL questions? Correct. That is all homebrew. Okay, alright, people, let's take a vote. They were off by 1 vote and in different pages anyways. Alright. Oh, that's actually unanimous. Alright. Really? I didn't expect people to really want to do the... Okay, alright. Chapter. Yeah, I'm sorry. We'll do it next stream, alright? It looked like people kind of wanted to do it anyways, but I think people are excited for this because this is the last TSTST problem that I haven't written up. Or solved and written up. So... yeah, I think people want me to just finish the whole collection. Next stream, next stream. The Mexico problem does actually look quite cool, for the record. So, yeah, I hope we get to do it next stream. But isn't it in the berry handout? Is it? It is in the really old berry handout, the one from 2012, where I showed it was possible to bury it with extreme suffering and pain. That is not what we are trying to go for today. Okay. Alright, we're probably not going to go to the other ones. Okay, so we have two circles intersecting. Sure. And we could put your favorite countries MO besides USA and Taiwan, which would be your favorite. Ah, that's tough. There's so many good ones. Oh. I'm gonna say Russia, but with very low confidence. I think there's a lot of countries have a lot of really good problems. I'll put it that way. So we reflect line A or 102. I also think there's like a quantity type thing. Like some countries will have more original problems per year than others. Thank you, Fury Guns, for the follow. Like for example, Russia definitely has like a lot of volume. Like their national Olympiad, the All Russian, has like different grade levels. Yeah. Like Taiwan has some good problems, but the good problems tend to show up on the TST, and there's not that many. They don't have that many original problems. It's just the ones they do have are on average like quite nice. Okay, so oh jeez, I painted myself into a corner. I wasn't expecting to have to draw T. Okay. Oh jeez, how do you draw a common tangent? Oh no. No, how do I draw the common tangent? Is there a tool? Why can't I construct a circle tangent to a circle and a line in GeoGebra? I don't know. Okay, we're gonna do tangent on both circles. Does that work? Tangents. Oh, it works! Haha! Alright, we're saved! Okay, L1. Yeah, I didn't know that was a command either. Cause the picture for the command was like it shows a point. Alright, P and Q. AX over PX equals what? What kind of condition? Wait. The heck is that? Oh, wait, that just means they're parallel. Okay, fine. I was like okay, so there's a parallel thingy. Moreover, PA and QA get extended such that wait, what? What kind of condition is this? Is that a harmonic bundle condition? It's like AR no, it's C times PQ. Oh, it's on the major arcs. Freak. Learn to read. Okay, that's a lot worse. Just waiting. AX over PX. Okay, how do I construct Y? Jeez. It's law of sines. Okay. Aww. Yeah, it's like by the rotation by the same. No. Are arcs AP and AQ equal? Let me first see if I'm silly. Yeah, they're not equal, so this is gonna be a pain in the butt. Oh, it's major. How do I draw this diagram? Someone please. Okay. Are the triangles going to be similar or something? No, no way, right? So something is similar to something else. I don't know. We're just gonna wing it. I give up. I officially give up. We're gonna call this C1 equals distance A x over distance px, and C2 let me make sure I define these correctly. AY over QY, AX over PX. Good. And now we just fudge them so they I want to show more digits, so let's do the so we're supposed to make these equal. That sucks. 107. Good enough. Okay, and then we extend PA and Q. What the heck? Such that, okay. So, R equals A plus A minus P times. Okay, maybe I should not make. What the heck is this condition? Okay, what the heck? Excuse me. Excuse me. I think it's C times PQ. No, oh, frick. Jeez. Excuse me. Does Y lie on AQ or ArcAQ? It should be Arc, I think. The heck is this condition? I should have done the Mexico problem. We did Cono Sur and 2008 and 4. Okay, so I'm gonna do what's called, we're gonna bite the bullet and actually construct the Apollonian. So, oh jeez, how do you construct the Apollonian? I take it for the angle bisector, right? Okay, x1 equals bisector. Okay, so y is supposed to be the point that intersect. So I would like to construct the harmonic conjugate of y1, and I can do so by y1 intersect polar of y1 with respect to the circle centered at the midpoint of AQ with passing through Q. Take that polar and intersect it with line AQ. I'm gonna call it Z because we're never going to look at that point again. And Z is probably really far away. Let me check that I responded correctly. Yeah, that should be fine. Okay, and then Y equals intersect omega 2 with the circle through y1 and I pick the other intersection. What? Hey, no, don't do that. What? Huh? No, I want Y to be the other one. Why won't you let me take the other intersection? I want to rename Z to Z1 to say, remind ourselves that it's useless. And rename C to Y. And YQ equals segment YQ. YA equals segment YA. And now, where is R? This was R. We're going to rename C1 to C because now it's actually the correct constant. And now we'll do this. Okay, so QS equals segment QS blue. We're going to hide the Apollonian that we constructed. We're going to hide x1 and y1 because they are literally... Actually, maybe I won't hide them. They might come in handy. I'm not sure. We'll see. But now O is the center of ARS. And XY is line XY. And I want O to be on that line. God freaking. Why doesn't the intersection change when I... The heck? No, I'm almost there. I refuse. We're not giving up now. Okay, C and then alright, now I have two distinct y points, y1 and y2. And one of them should always be correct. So at this point when it flips, I'll say instead y equals y1. Haha! Ha 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 ha. The frick? Why can't I get it to... Oh, it's O. I was looking at the point S. I'm... Okay. I was like, why won't it pass through that point? Okay, we did it. We have succeeded. Alright, so what am I supposed to do with this now? So the angle bisectors, yeah, like I feel like I understand none of the conditions in this problem. Other than there's a bunch of, let's see, PQ, AR against PQ. Like, what is AR against PQ supposed to be? If it was like PR, I would be less more happy. Can you scroll left? Is it like, are those things gonna concur? They might. I mean, you can't really tell. Oh, let's move some stuff around. Yeah, it looks like XY is gonna pass through the. That's a little too. That's a little too coincidental. Let me try it one more time. Yeah, that's too coincidental. I bet they concur. Then there's nice mothety things. Yeah, I guess X and Y should be images under. That seems too good to be true, actually, now that I'm looking at this. Like P maps to Q and X maps to Y. What if we randomly draw in a third circle? I feel like XA and YA might be tangents too. Like, I think maybe you have like AY might be tangent to Omega 1, and then AX might be tangent to Omega 2. And that explains the times C condition, because then it says the spiral, there's spiral similarity sending like XPQ to XAR or something. Or something like this. PX, yeah. I feel like I tried a few cases and it was so coincidental. I'm convinced that they concur here. Red lights are... The problem is that they're only parallel when like O lies on XY. So like the diagram will always be off by a little because I'm eyeballing the O lies on XY line. Right, like if in general it's not true. I need the special case where XY passes through O. But I don't understand what the point X is doing. Like, what the heck? What is ARS? Like, what is that? Who are you? Yeah, one variable inequalities is probably calculus. I have a thought. What if the C's aren't related? That would be the most masterful bait of all time, but I can see that happening. What if this C... YA... I want to check this. I'm curious whether it's the same constant. Because if so, I can drop that condition. Wait, why are C1 and C2 different? AX over PX. Oh shit, I misdefined it. Yeah, cool. They should match. Okay. Sad. Okay, that was worth a shot. Okay, anyways, what does the problem want me to prove? I actually haven't looked at that yet. XPA is equal to YQA. So like, this arc is equal to that arc. Is that true just if they're parallel? Yeah, if they're parallel, then the arcs are automatically equal? Maybe? Is that true? That seems like it's long shot. Equal if and only if parallel, if and only if concurrent. I agree, concurrent if and only if parallel. Why does parallel imply XPA equals YQA? Is that obvious? Am I being dense? If you look at the image, don't you need AT perpendicular to XO1? Okay, so I'm going to, you're asking me to construct the, we're going to call it A prime. It's the intersection of the line through Q parallel to line PA against so that okay, why is that always, that doesn't depend on, okay, why is this triangle isosceles? Because this angle, okay, should I should just follow from the tangent? AX over PX condition. Oh, what? Oh, so AX over PX and oh, that's so smart. Okay, so genius. Okay, so this homotopy thing tells me when I do this. So if X and Y were images, I would then say this is equal to this, but then this is equal to that. Same ratio. Yeah, XP maps to QY, and then YA prime is like yeah, it's like a copy of this. Oh, so even if I don't assume anything, if PXA maps, no. Okay, breathe in, breathe out. Okay. XPA maps to QA prime Y is the hope. If X maps to Y, then it does. And then PX is QA prime Y, and then YA is equal to YA prime, and so you'll get to angles are congruent. So AQY equals A prime QY equals APX. Okay, got it. I understand. So what we have is that So if we claim that x maps to y via homothety, if so, then done by noticing directed angle a prime y q is equal to axp, but also equal to whatever it is, px c inverse times. So direct angle cool. Alright, that's fine. No, so now I just want to figure out what this point O is doing and what the points R and S are doing. So there's a spiral sim, right? XP, like XAR is equal to we have an unconditional spiral sim actually. I don't know how I didn't see that earlier. Like we always have direct angle XAR is equal to XAP is equal to angle XPQ. And since AR over XR equals yeah, so there's a spiral similarity at X which takes XPQ to XAR. So phrased a different way, spiral similarities come in pairs. So that means there's one taking XQR to XAP. Ratios mean spiral sim normally, right? I wouldn't say usually, but it is certainly a very good way of handling them. Like it's pretty common. No, did I screw up? It's AX. Yeah, AX is fine. Yeah, XPX. Okay. Okay. Midpoints, I think, is probably what people were talking about. So I've used up, I think the C condition is sort of mostly used at this point. Like it gave me 2 spiral sims and then also tells me I want to show X maps to Y. What does that have to do with ARS? Well, I have control over XAR. I can switch it from control over XPR. So doesn't tell me anything about this. XPQ and XAR. What do I do with this? Yeah, I don't get it. What is AX? What are? I know there's this spiral here, and I don't know how I can use that to get something. XAR. Like I have control over either triangle XAR or triangle XQR. Maybe AR is better. I can say like you like the perpendicular bisector of AR or something. It's rotated from perpendicular bisector of PQ. Y is on or not the light green circle. It's not on the light green circle for sure. Because if it was, then X should be by symmetry, which is not the case. Uh, hmm. Man, what am I supposed to do here? XAR. So what do we want to show? Our goal is to show that x is the image of y under homothenity at t. That's where we are. And I have a spiral sim that I don't know what to do with. How old are you? I'm 24. What is the locus of O as you move x and y? Oh, maybe it is a line. Yeah, the locus of O should be a line because it's formed by the intersecting these two perpendicular bisectors at fixed, and these ratios move linearly. So it's something like, okay, like XA, this ratio is equal to whatever it is here. like XP over PM. And this is equal to like XP over XA. Let me name these. Is the locus OM? Yeah, it's OM for sure. And the reason is that you can I can calculate what this thing, like this length A and R is AR over 2 is, so it's like C halves times C times PM. So it's a spiral sim that takes XPM to XANR. And so that, and this is oh, hang on a minute. Wait. Circle A and R. Oh, they are equal. Yeah, okay. So, like, A and R is equal to A and S. So, AO is actually an angle bisector? And it's like... Okay, oh, bisector. That seems like I should care about it. Yeah, it's because AR is equal to A. Oh yeah, that's... Yeah, it's an angle bisector. I'm taking the isosceles triangle. God damn it. Yeah, so it's just the angle bisector. It's one of those days. That's silly. I shouldn't miss that. So it's angle bisector. I'm curious, what's the angle bisector of angle PAQ look like? It passes through anything interesting? If PX and QY are parallel, we don't know that. That's what we're trying to show. Maybe this parallel to all of them. Yeah, it's possible this line AO is actually also just parallel to XP. Let's check that. Bernoulli is only enough for Z less than 0.9962. I mean, that's fine. Just do something else for the other case. Yeah, if AO is parallel to PX or QY, then that is what we want. Okay. So AO looks like it's... Okay, fine. So it's like I want SAX equal to RAY or something? Or angle SAY really, or something. Is PA equal to XO? No way. If PA equals XO, then QA equals YO. Actually, that might be possible. I don't believe it though. Yeah, that should be false for symmetry reasons. Freaking. Bash. What would I do though? Like, I don't have a setup either. If we reflect Q over Y and AO, what happens? So that's Q over AO. And Y over AO is somewhere down there. I don't know if you expect something out of that. What are you? What are you reflecting? Q over AO? What? I don't know why it's not up there. Like, this is line AO. It looks there. You want YBQ prime collinear? Doesn't look like it. Oh, why was somewhere way south? But I mean, I didn't see anything coming out of it. Maybe I should actually use my spiral simulator. So if I was spiral simulator at X. Oh, that looks like it's going to be very useful. Okay, is that really true? So XPQ, then YPQS, right? Also. Yep, alright, yeah, alright. Alright, let's click. I'm gonna hide this stuff that I don't think matters anymore. Where's this one? Don't think I need that. I don't think I need that either. These points are distracting. Wide frame is a distraction. Okay, so is this true unconditionally? If I like... Yeah, it's true unconditionally. Why is that cyclic? I don't know. I just noticed it just now. I really... should have called him earlier. Not only is it cyclic, I think when it's cyclic it passes through like a useful point here. Oh, these circles are very strong. These second intersection points are also showing up now. So, why is this the case? Actually, first of all, does that unconditionally pass through? Alright, we're gonna... Let me just do it. Alright, we're onto something. This is going somewhere. Okay, so why is XPQ cyclic? XPQ are cyclic. I told you there's a spiral sim, right? That sends XAR to XPQ. So XRA is equal to XQP. Wait, is that it? No, spiral sim is supposed to work that way. What? Oh, it's because PA are collinear, right? Okay. So XRA equals XRP equals XQP. Okay, so we get that cyclic quad just out of the spiral sim. Like XPQR is always cyclic. And then YQPS is also cyclic. So if that's the case, then by power of a point, the other intersection here we'll call it X prime. Okay, so we'll rename this to X prime. And we'll name this other intersection point Y prime. Okay, so the spiral sim will tell you that TXX prime and TYY prime, yeah, like they should be homothetic things because of power of a point, I think. Is that true? Yeah, by power of a point. So if PQY prime, then Y prime should pass through T. This is unconditionally true. follows by some homotopy argument. So where does that bring O into the picture? Can I get anything about point O? Maybe I try to do a phantom point argument. So if I have all this information, let's take the case where can I show in this picture that OR equals OS? What can I do a phantom? Thank you, Marianne Patino 23 for the follow. Why are PRQX cyclic? Oh no, the PRQX cyclic follows from the angle chase. No, we actually do have PQR, part PRQX cyclic. From this unconditional spiral sim, we get the cyclic quad by another angle chase. Yeah, we should know PRQX cyclic by now. The reason is that angle XRP yeah, that angle is equal to that angle. Yeah, that cyclic quad is actually unconditional. I don't know what I'm supposed to do with O. Like, this angle bisector is not moving, and then eventually O is on the green line, and when that happens, I want to show like everything lines up, and I can't get it. Frick. Can I get something from that cyclic quad? I don't see it. What am I not seeing? Is A y prime S sim spiral sim to A O Y? Oh, that would be so nice if it was true. Oh man, it doesn't look like it's true. Is it true in the desired state? Well, I guess sort of in the desired state, like everything is true. Actually maybe not. Those numbers don't look the same. Do we need diagonals PY and QX? That seems advisable. I'm gonna draw this. Ah, frick. I don't get it. Like, how do I deal with that random point? Oh. I concur with Omega 2. I doubt it. Hi, Mark. I'm getting wrecked. Yeah, I just don't see what I'm supposed to do with this. Does X prime Y prime pass through a fixed point? Maybe. I don't think it does. Should I just invert from T or something? That doesn't do anything good with O though. Like the whole problem is I don't know how I'm supposed to handle the circumcenter. Like I can kind of have a sense that the angle, the fact it's the angle bisector of RAS matters, but I don't really understand the circumcenter part like at all. ABM collinear? Yeah. No, ABM collinear is definitely true by radical axis. Like, the radical axis always bisects the common tangent. I just don't see that why that does anything. Length batch and find AO based on C, PQ, and compare it to the length of the bisector of AXY. I don't think that's tractable. I don't think that's tractable. If we're going to invert, it's through T. Because T swaps P and Q, A, XX prime, Y, and Y prime. But I just... Nothing I've seen convinces me that this O, like, we know what to do with O. It's so late, yeah. We've been stuck on this for a while. Yeah, I construct points G and H such that X, P, G, and I want to construct harmonic conjugates. Then is GH parallel to PQ? What the heck? Where did that come from? I think I need to sleep. I mean, it might be true. I just don't know where you got that from. Like, I don't see anything that feels obviously projective. Like, everything so far feels spirally. Like, especially we have an explicit spiral stem XAQ to XPQ to XAR, and it, you know, does spiral thingies. In fact, I want to draw XAR again, and I'm running eyes. Things try. So this is the property that I think RQ should be tangent to this as well. I don't know if that does anything. Are PX and QR tangent? To XAR? Not PS, but not PX. Or wait, so QR is actually tangent. That follows my spiral similarity we computed. Yeah, like that one is actually tangent. But I don't. Like I don't see what it does. Like I just don't have any control over this freaking point O. What am I supposed to do at this point? Are you sure OXPA is not a parallelogram? It can't be by symmetry, right? Like if it's a parallelogram, then also Q by symmetry AQYO is also a parallelogram, which is like not happening. Unless it's like some config issue thing where like one of them is a parallelogram, the other is a trapezoid. Which I guess is possible. Alright. How do I check that? I picked a different picture, right? Yeah, that's not parallel. Py prime abqy concurrent. Yes, by radical axis. So you're saying I should draw the okay. Like, I mean, yes, but what does that do? Like, I can also draw, like, for example, the intersection of line PX and QX prime. And well, that's what it looks like. It's this giant line. We've intersected some radical xi, fine. Oh, I don't know what you do with that. Well, it's... well, that's a disappointing way to end off. If you prove if we prove the x through y homotopy, we are done. We've had that since the very start. Inverted A. Honestly, that might work. I might believe inversion at A. So ARS is still like isosceles. What happens if I invert it? So I have this all this spiral junk. Can I? How much of it can I preserve when I invert? Yeah, I could invert. Did you? Yeah, the spiral is all proven. Yeah, the spiral stuff on that's written up there is all proven stuff. So you have a spiral simulator that makes XPQ to XAR, and one that maps y the symmetric thing ypq to yps. It gives you points x prime y prime q on those circles. It gives you the green circles. The only thing we don't know what to do is like what the hell is the point O? Like I just I know there's something I'm not seeing. Does O go to the same point in both of them? You seem bored. I just don't feel like I'm getting anywhere. It's enough to prove that AP over AQ equals TP over TQ squared? Wait, what? Why is that sufficient? The heck? O goes to the same point in both of them. So if I take XAR to XPQ through O, it lands on some point through there. How do I determine that point? Yeah, XAP. Wait, what? XAP is similar, XPQ. Yes, I assume you meant XAR. But yeah, we have that spiral sim. Thank you, LSRS. Laser US. What the follow? How do I figure out where O goes under the homology? AOR is supposed to map to PQ and that wherever that point is. Thank you. Entry for flow. Because AR is equal to PQ. AR is equal to PQ? No, it's not. What? This looks fun. Yeah, but I'm really getting destroyed here. Do you need to know more than analytic geometry to solve this? What does more than mean? I'm not planning to use any analytic geometry, but we're using spiral similarity. I never drew that circle XAR. Don't know much more than algebraic geometry. Well, welcome to the stream. When O's on XY, the two original circles are orthogonal. I don't... Which two original ones? If you mean this O1 and O2, I mean, no, because they weren't orthogonal to begin with, and, like, X and Y don't move those circles. How hard is a Putnam compared to the IMO? Depends on who you ask. The flavor of problems is definitely different. I personally think the IMO is harder. Or has more depth, I would say. Are we not inverting? I don't really want to, honestly. I would tolerate inversion at A. Inversion at T also seems like it might be promising. But I just feel like that there's something here. Like, we have spiral sims that we haven't really used. We have this R. Like, in so much as we don't know anything about O, we also really haven't used R, like, just at all. And I'm like very frustrated by this. I feel like I should be able to do something with this point R, but I don't see it at all. O prime be the image of O under either spiral similarity. Okay, which O? Then XAO spiral sims to XPO prime. Draw PR. What is PR gonna do? Wait, PR is already drawn. Okay, so this is the angle bisector of the blue things. We don't know AX and AY are orthogonal in the red thing. That's what we want to show. Left for a while. You didn't miss much. This problem has been really... this problem's not going well at all. Invert. I really didn't want to invert. I might... I know I'm supposed to use that spiral sim, and I can't get it. So there's a spiral similarity. The spiral similarity at X maps the blue point to the orange line, and then maps the orange line to the blue line. Where does it take things? Like the composition of two spiral sims is a spiral sim. T and A need to be on the same Apollonia circle. Yeah. So XY. Okay, so I need to I want to compose two spiral sims. I think that might do something. So XAR, there's a spiral similarity at X, and it maps R to Q, and the spiral similarity at Y maps it to A. Right? There's too much junk in this diagram. Holy crap, I can't see a thing. Cleanup time. I'm actually gonna hide green circles, even though I think they're really good. Yeah, so Y, yeah, there's a spiral sim that maps R, maps to... But we didn't use, like, we said there's a spiral sim and then didn't do anything, right? Like, that doesn't mean we've used the point up. So the spiral sim, like, where does this? There's a. If I compose the two spiral sims, it sends R to A, and it sends A to S. Maybe? Okay, wait. Actually, where does A go under the spiral sim at X? At Y? No, at X. Okay, so R maps to I guess R Q A. Meanwhile, S maps through X to nowhere. Okay, well, shoot. A maps to P. Where does that map through Y? To S. So, okay, so if O is on XY, then something's gonna happen. Okay, alright, okay. Cool story. Well, so I guess we're composing spiral sims. It takes, the first one takes, so through X, the point R goes to Q, goes to A. And through, if I do it again, A through X goes to P, which should go to S. Is that right? It's so much harder to see the Y spiral sim because I've been staring at X the whole time. Okay, so fine. This is called rotation because AR equals to AS. So a spiral sim is determined by 2 points, right? This is a spiral sim that takes segment RA to segment AS. Yeah, that's rotation through O. So the composed guy is centered through O. Now, what about, where does X go? If I do... like the center of the spiral similarity, well, what's going on here? So X maps through, it's fixed under the first one, and then through the Y it goes somewhere. I don't know what that means actually. So if the composition of two homotheties has its center, what does that tell you about them? Or better yet, why don't I feed O to the homothety? Like, I expect it to land back at O, so that will tell me some non-trivial information. It tells me that so where's the question mark point? Oh, we're getting somewhere now. Oh jeez, I was about to give up. that's how you use O. It's the center of spiral similarity because it's rotation. So O goes to, how do you compute the center? I don't know. It's the O prime you described earlier. Okay, let's actually draw a point in. That seems like it'll be a useful point then. How do I construct it? Can you just do complex? Good idea. So the O prime is the image through a spiral sim centered at... Okay, let's check that worked. Okay, so there's a magic point O. We'll draw it there. And it lies on things. So... you are composing two rotations and getting a rotation. Well, the spiral sims are not just like the XPQ to XAR is not rotation. There is a scale factor, but it's canceled out by the scale factor going the other way. So what does that tell me? Okay. Oh lord, it's still this problem. Yeah, sorry. I spent the last like, oh my, how freaking long have I spent on this freaking... I'm so annoyed. Based on the chat logs. 10:30. Yeah, it's been about 2 hours. But like, a lot of that was me just staring at... Shouldn't the composition of two rotations be a reflection? Wait, what? No, that's not true. Yeah, I'm annoyed. I spent so much time just staring at the picture and not being sure what to do. What program is this? This is GeoGebra. But I was supposed to compose the spiral sims. Am I sure I constructed O prime correctly? I think. Invert? No, I'm not inverting. I just got the spiral sim. Ah, I'm so aggravated right now. Oh my god. Okay, so the y xap goes to x o prime, right? Oh. No, what? Okay, what are we constructing? Someone please explain. Wait, okay. Shout out to VEnhance from AOPS user 305. We should be almost done. Is there any reason you never did this problem? I just never got around to it. I wasn't good enough to do it when I saw it on the actual test, and then the condition looked really strange, so I never really wanted to work on it after that. Thank you. Energy is always conserved for the follow. So XPQ goes to XAR, XQP. Let me just write out what the so XQP XPQ through X goes to XAR, and sorry, PQ through X goes to AR, but also through Y, through the inverse map through Y goes to SA. No, I have it backwards. Let me write it consistent. Segment AR maps to segment SQ. Okay, I'm just confusing myself at this point because I'm tired. So XARO should map to XPQO prime. Okay, I see. I drew the O prime in the wrong place. Yeah, this is the... I flipped this. Oh, would you look at that? What point is that? Are you going to game today, or is the live soft talk taking too long? It's because of this fucking spiral sim problem. I'm so fucking pissed. Ugh. Like, literally, this 1 hour. Yeah, I'll play some games after this because I need to de-stress. I'm so annoyed. I don't think I need X from Y from anymore. No, we're almost done. We have the. I feel like we're almost done because I got the spiral sim composition. That's the part that I was missing. Like, the part that I was missing was I was supposed to compose the spiral sims, which, whenever this happens, it never feels natural to me. Like, it doesn't feel like I put two synthetic things together or something. Like, it's more abstract or in some way, and yeah, so I'm not surprised that nothing we tried before worked. Yeah. I should have tried it earlier, honestly. I just didn't think to, because I don't use it very much. O prime is fixed since AOR equals POQ O prime Q. Angle AOR. Yeah, you're correct. It is fixed. So triangle AOR has a fixed shape, so yeah, it's whatever. There's a fixed O prime here. Now, if it lies on line XY, what does it mean for O to lie on XY? Like if I compose two spiral sims, yeah, so O is a nice fixed point, and it so XOO prime through the spiral sim is similar to what? AOR is fixed. O prime PQ maps to OSA. Hang on, what? Yeah, so XOA. Fine. So angle XOA by spiral sim is XO prime P, which apparently is equal to YOA, which is, I think the angle dump is the right to go. So apparently XO prime P equals YO prime Q. So like XO prime Y is equal to PO prime Q. XO prime Y is equal to PO prime Q. O prime PQ, AR, POQ fixed, so that doesn't say something. No, it has to say something, right? Because it's not always true that XOA plus YOA is 180. Like XO prime P. The tangent at A to the circumcircle of ARS really looks like it goes through T. That's definitely false. The tangent at A is the perpendicular line through A and line AO. Or maybe, no. Yeah, that's a tangent. XO prime Y, PO prime Q. So, okay, XO prime Y. I feel like I'm still missing something I'm not understanding, because it's like the spiral sim lies on the line joining the center of the composition lies there. Like that says something, but I don't know what it says. Like if I have I need to think this through. I don't do this kind of thing enough. Like, if I have to... the not rotation transform. But they're not... They're spiral sims, right? They're not just plain rotations. Like, the scale factors, I don't think they commute with rotating. No, the dilations like a spiral sim is the same as a rotation followed by a dilation at the same center, but the dilations don't cancel because like it's rotate dilate because you're putting two of them together, and the rotate through A, dilate through A, rotate through B, dilate through B, like the like if I dilate through some factor at A and then some other factor at a different point B, that is not. They don't cancel. How long have you spent? It's been like 2 hours. I'm very angry. Yeah. So XO prime Y should be I believe that. Yeah. XO prime Y. I agree that rotation and dilation through a common center commute. However, the centers are x and y respectively when I compose the two things, and x does not equal y. Actually, is XO prime y always similar to... No, it's not. So when this happens, these two guys are similar. Okay. What do you need on JMO to make MOP? It depends on the JMO. Wait, does that pass through B? That's really convenient if that's true. I don't know if that's relevant. Huh, okay, I learned something new today. Yeah, so O prime is the point such that, like, on that circle where I did that reflection. And, like, I don't know, something happened. Whatever. B is useful. I don't think it's useful, it just happened to show up when I drew it. O is the center of this rotation, sending AR to SA. that rotation goes through PQ. This should be almost there. It really should be almost there. I would really like to have an angle bisection. I don't know if that's gonna happen, but that would certainly make life easier. Yeah, I would believe rotate, transform, rotate. So XO goes to XO prime, maps back down here. It's like rotated through this angle. I don't know. Like, okay, pretend they're equal. You got your angle bisection. Okay, so XO over XO prime is XA over XP. Okay. It goes YK over YA. You can tell I'm tired. Okay, so XA over XP. It should finish once I have the angle bisection. So equals OY over O prime Y. Oh, wait, why does that do an angle bisect? So I agree that it tells you that, like, this over this is this over that. Wait, I don't see why this gives... Which angle bisection are you claiming? Oh, O prime O bisects. Yeah, that's true. That wasn't the angle one I had in mind, but... On the other hand, the spiral sim should give me some random angles very cool. Okay, so... So O prime O... Wait, does it map anywhere? Does that have something to do with Apollonians? It looks like it. Like, so, I know that AO is supposed to bisect XAY. Like, I'm pretty sure that's equivalent. Also, another condition that would solve the problem. XO prime over YO prime. Actually, XO prime over YO prime. The XO over YO. Wait. Hang on, I'm confused now. Sorry, it doesn't bisect it. What am I talking about? I thought it did somehow. Ah. Thank you, right for the justice for the follow. Should be almost there. Where am I? Yeah, I can see OO prime. There's a definitely Apollonian there. I don't think that solves the problem outright. XPA is XO prime O. Oh, what? Yeah, that is true. Yeah, that is what we wanted, right? I got so sidetracked by this point O that I didn't. Okay, so what happens is the collinearity makes the angle bisector theorem apply, and how on the other hand angle XP it's there for the angle bisector theorem. Okay. So I don't even need this. I can just. Okay, we did it. The frustrating thing is, like, I know we were close the whole time. Well, not close. Sorry, close is the wrong word. I knew that there wouldn't be a lot to do. Like, I knew that I was going to use the spiral sim somehow, and it wasn't going to be like very involved. But man, I just could not work it out. Jesus. Yeah, so R and S are, yeah. The spiral sim was like just. What a sad problem. So what did I use the whole time? Just the spiral sim? Is it literally like the spiral sims compose and then I want to see just how little stuff that I used. I didn't even use the point T. I thought for sure that T was going to be involved, but it turns out to be superfluous. Tangencies are not really involved either, I think. Yeah, I didn't use this point. Didn't use this center. I never used that center either. I didn't even use the fact that O prime was a particular point. It's just some point somewhere. I didn't use this midpoint. I didn't use the point B. I didn't use this circle. I didn't use this. I didn't use this line. I didn't use T. So this is what we used. The argument is that by condition, XAR is spirally similar to XPQ. That's unconditionally true. Also, the other one is spirally similar unconditionally. So we can compose them because it sends RA to AS, so it's centered to O. And we can let O prime be the image. Then, if O lies on here, then first of all, angle bisector theorem applies because we use the same constant C here to say that because these are the same constant. Hang on. XO over XO prime, XA over, yeah, they are C. Because the same constant was used here, the angle bisector theorem then applies. And then it gives you the angles and you copy the angles. That's the complete solution. Yeah, we actually, I think T really hurt us. That point, T, it really burned. I didn't use this triangle for that matter either, or this line. I don't really care about the line. I care about segment PQ. So now I know why this is number 2. It's like, oh my god, we got baited. We got baited. Yeah, once it starts, it's like, oh my god. The only thing that happened was you translate the angle into spiral sim, the angle bisector theorem applies, uses the last length condition, and then that's it. It's just a spiral sim problem. That's it. There's no geometry. Almost no geometry. You have to like notice that like this angle is equal to this angle. What a stroll. It's all because of that point T. It's all T's fault. I blame point T. What games? Do I want to play any games at this point? It's like 1. I'll play a little bit of something. I don't know what though. Anyone have requests? Scribble? I'm sorry, I'm not in the mood for Scribble right now. You finished BSBS, right? Oh, Baba. No, I haven't finished. I have about 7 levels left and I've been leaving them because I don't want to run out of Baba levels. I can't bring myself to finish the game. So I left the last levels for whenever I really want to play Baba again. I finished like nearly all the levels. It's not like I left the 7 hardest ones. There's just 7 levels like scattered around the first map that I never got to. And no, there's only I don't actually know if the number is 7. It might actually be like 5 or something. But like some single digit number of levels scattered in the first one that I never got around to doing. I've told myself I'm gonna wait until I can have friends over and then we can finish the levels together, and that will be a bonding experience. So I'm saving them for after this goddamn pandemic. Wait until Baba has a level editor. Baba already has a level editor. Did you know? Here, I'll show you. Level editor. It's kind of janky right now. I also don't know how to quit. Yeah. It's not ready for public use. How to join the voice channel sub VIP? You should subscribe to the channel and then you can access the sub channel. You're not actually expected to subscribe unless you have Twitch Prime, because I think that's a silly way to use some money. But I don't know, for the people who are willing to give me $2.50 a month extra, by which I mean they have Amazon Prime, so it doesn't cost them anything. They get to be yellow in their name tag and feel a little special or something. I don't know. The Twitch sub. For the FTW. I want to play some StarCraft. I have been meaning to play for a while, and I haven't gotten a chance. Well, of course StarCraft needs a patch update. Alright, good night ALS user, thanks for sticking around. Huh, is my wine broken? I upgraded my drivers recently, so it might cause problems. That's sad. Oh, maybe it'll work. Let's find out. Beautiful. So in my infinite wisdom, I managed to... I tried to activate my StarCraft keys, and somehow I pressed shutdown instead and shut down my entire computer. So it's one of those days. Yeah. I literally just pressed shutdown instead of... I have a keybind that changes my mouse buttons for StarCraft purposes, and it's bound to S on a certain... on win super plus escape. And then I have another hotkey sequence for shutdown, which is also bound to S on the super plus power. And then I press the power button instead. So that was ill-advised. Don't do that. Okay. Alright, we're back now though. Alright. Okay, time to throw away some MMR. It's been a while since I've played this on stream. Actually, it's been a while since I've played at all. Where was the race the other guy? Protoss. Okay. No! No! Don't alt tap. Oh my freaking god. Now everything's thrown off already. They try to tell me that battle.net encountered an error and needs to close, which it does very often.
Warp in more pylons. Try for a proxy maybe. Your probes are under attack.
Yeah, everything's already off. Jesus.
minerals. Need more minerals, but there are plenty of rocks.
Okay. Da-da.
The firstborn shall persevere.
Wait, that's not.
Yes?
You can't warp in there. Pay attention.
I forgot that because of the block, I could have gotten the robo. That was stupid. I should have considered
I
it.
am here in the shadows. You require my skill.
I'm really bad at this game.
I am the voice. Cold, it is one with the shadows.
Research complete.
I am here.
You're short on minerals. Are you saturated yet?
Okay.
You have not enough minerals. You require more Vespine gas. Need more Vespine gas. Might be time to expand. Not enough Vespine gas.
Okay. Let's take the forges.
Not enough minerals.
I return to serve.
We require more minerals. You must construct a pylon. Not enough minerals. Insufficient Vespine gas.
Alright.
You have not enough minerals. Need more minerals, but there are plenty of rocks. You're short on minerals. Are you? My dad always.
I return to serve.
Not enough minerals. Mineral field depleted. You're out of supply. You must.
Jesus, this is a really nightmare.
Are you auto? That field's been mined out. We have an expansion.
On the way, I return to serve.
You have not enough minerals. That mineral field go up. Need more minerals, but there are plenty of rocks.
I feel your presence.
Time for battle.
Upgrade's done. To what's up? You're short on minerals.
Highlight for iron.
Warp field online.
The merging.
We require more minerals.
Engaging the enemy.
You have not enough minerals. Not enough minerals. Need more minerals. But they're... That field's been mined out. Hope you have an expansion.
Stay united.
Let's place that in a power field.
Highlight for iron.
You can't warp in there. Pay attention. We
I return to serve. Highlight for iron.
not enough minerals.
The merging is complete.
You're out of supplies. Probes and pylons.
Highlight for iron.
This upgrade makes your unit stronger. Warp in more pylons. Try for a proxy maybe. Base is under attack.
We embrace the glory of battle.
Your base is under attack. Stay cool. Need more Vesting. You have not enough minerals.
From the shadow.
Oh, did I lose the fight? Probably also. Ah, disaster. That's what I haven't seen him play this game for too long. Yeah, it was completely. It was a complete mess. Ah, jeez. Some.
Warp in more pylons. Try more approximating. Your probes are getting owned. We require more minerals. You're short on minerals. Are you saturated yet?
Jesus.
You're out of supply. Probes and pylons. Not enough Vespine gas.
Glory to the Daylong. I am Najakar Mina. Combat awaits. Yes, execute.
I'm here in the shadows.
Need more minerals, but there are plenty of rocks. Research is done. That one's been in but for years.
Everything's off. Oh my god.
You have not enough minerals. Not enough minerals. Need more minerals, but there are plenty of rocks.
I return to serve.
On pour call.
Our forces are under attack.
I return to serve.
For honor. Engaging the enemy.
You must construct additional pylons. You're short on minerals. Are you saturated yet? We require more minerals.
The firstborn shall persevere.
Not enough minerals.
Are you serious? Oh my.
You have not enough minerals. Don't you need a geyser for that? You're short on minerals. Are you saturated yet? You must construct additional pylons. That mineral field's gone. Looks like we're going to the lake. You're out of supply. Probes and pylons. You can't go in there. Pay attention. Proton.
Engaging the enemy.
They're one.
Glory to the day.
I return to serve.
We require more minerals. Need more minerals. Not enough minerals. You have not.
The firstborn shall persevere.
You can't warp in there. Pay attention.
Is the voice in?
Upgrade complete.
Yeah, the voice is saying, "Is your are you saturated yet?" And that is the correct one.
You can't warp in there. Pay attention. You can't warp in there. Pay attention.
Frick! I about messed with my
Upgrade's
hotkey.
done. To us, Mineral field depleted. That field's been mined out. Will we have an expansion? Research? You're short on minerals. Are you saturated yet? Insufficient Vespine gas. You require mineral field depleted. Need more Vespine gas.
I return to serve.
What guide we you require?
You must construct additional pylons. Warp in more pylons. Need more minerals. But there are plenty of rocks.
I return to serve.
I have no context for it. Yeah, I mean the voice is like obnoxiously high pitched. Oh. I don't know. People make fun of the DeFi announcer, but it's comedic.
Insufficient vesting. They're attacking your probe. Watch your mineral line. Your probes are under attack.
Glory to the Daemon.
They're going after a pylon. A classic tactic. You can't warp in there. Pay attention.
We embrace the glory.
That needs a power field. Ah, 귀찮아.
We will comply. The enemy closes.
That field's been mined out. Hope you understand. Power field for that. They're one weakness. That mineral field's gone. Looks like we're going to the late game.
Oh, fucking pieces.
We embrace the glory of battle.
They're attacking your base complete.
Okay, stalkers it is.
I am here, shadow.
Your base is under attack. Stay cool. They're attacking your probe. Watch your mineral line. This upgrade makes your units strong. Your probes are getting owned. Base is under attack.
Oh my god.
How is that?
That is an oversight. Well, I guess I can resaturate those mineral lines.
Your probes are under attack. You require more Vespine gas. Your probes are getting owned.
Let our enemy know our fury.
Oh god, I'm so bad at this.
Veraku, I am. We are at full power.
Not enough Vespine gas. You must place that in a power field. Need more Vespine gas. Upgrade complete. field's been mined out. Hope you have an expansion. You can't warp in there. Mineral field depleted.
Shadow element is vessel.
Insufficient Vespine gas. Pylon under attack. Did you warp in a backup? You can't warp in there. Pay attention. They're going after a pylon. A classic tactic. Pylon under attack. Did you warp in a backup? You require more Vespine. You must complete. They're attacking your base, you know. That mineral field's gone. Looks like we're going to the late game.
Okay, I lost this one as well.
Base is under
Thank you,
attack.
J-Park, for the
Upgrade
follow.
done. To what's up?
Man, Alright, back to plat 3. I haven't played this game in so long. Jesus. Yeah. That was a bad fight. Yeah. Alright. I think I'm done. Alright. Thanks all for coming out. I'll see you next time. My god. One of these days I want the stream to actually go well. I feel like the last few have just been like... just nothing's working these days. Alright, see you all. Good luck to ULG taking TST next week. Hopefully it goes better than everything today did. Best I could offer.